Hi, welcome back. Once again, I am welcoming you all to this beautiful online learning platform, Unacademy. Unacademy is the India's largest online learning platform. So once again, I am welcoming you all to this beautiful online learning platform. Now we are happy to announce that Unacademy is going to providing online training for GATE and engineering service examinations. Here your classes are taken care by India's top educators who are toppers from IIT, who are toppers in GATE exam, who are the toppers in IES, okay, and well experienced faculty are going to handling your subjects. About myself, I G Venkata. I have 16 plus years of teaching experience. So far I mentored more than 60,000 students for their GATE examination. At present, I am pursuing PhD from JNTU Kakinada and my specialization is VLSI design. Now, first we check how to get Unacademy learning app into your device. Just go to Play Store, type Unacademy. Okay, by typing Unacademy, you will get the Unacademy learning app like this. So, Unacademy learning app you get like this. In this, just by clicking on this install button, it will install the Unacademy learning app into your device. Next, see what you will get. So by joining this Unacademy, what you will get, that is very important. First and foremost important thing is you are going to getting a daily live classes. Every day you have a online class. In that daily live class, the intention behind to taking the classes regularly is always to keep the student in touch with the subject. Okay, so that is the intention. Now in that daily live classes, so you can chat with your educator and you can engage in discussions and ask your doubts and answer polls. By participating polls, you can enhance your skills. That is the first and foremost important thing. Second one is structured courses. Structured courses. In this structured courses, all our courses are structured in line with your exam syllabus. Exam syllabus. For your exam, what exactly required? For your exam, what exactly required, that is going to be structured well. Then it is very easy to you go for preparation. And third one is live tests and quizzes. So once you complete your preparation, then you need to write exams on that. More number of tests you need to write on that. Okay, to know your performance in that exam. Okay, so to evaluate yourself, your preparation, okay, you can evaluate it with our regular mock tests and quizzes and get a detailed analysis on your performance. Okay, after that, get the detailed analysis on your performance. After that, unlimited access. Unlimited access. In that unlimited access, once you take in a subscription, you can access to all our live and recorded courses to watch from the comfort of any of your device. So by taking this subscription, once you take in a subscription, you can get that live classes you can attend, and you can get the recorded courses. For example, yesterday you were absent to class. Now today you are free, so you can go for that recorded session. Whatever the class completed yesterday, that recorded session is available in your app. Go to that and enjoy the session. That facility is there. And most important thing, no need of any tab, no need of any laptop, any desktop, just your mobile is sufficient. If you have those devices, you can use it, it's not an issue. Okay, here that comfortability you have. Okay, any of the device you can go for it. That facility is there. So next one is, there are two subscriptions, iconic subscription and plus subscription. In plus subscription, there are daily live classes. What are the things just before we mention? All those things you get: daily live classes and structured courses, live tests and quizzes, unlimited access. You get all these things. Okay, by plus subscription. Okay, sir. So in this live classes, you can chat with your educator, you can engage the discussions, you can ask your doubts and answer the polls. Okay, you can do different things, and your exam syllabus is properly structured for your best preparation. And live test, to evaluate your preparation, you can evaluate it with our regular mock tests and quizzes and get the detailed analysis on your performance. We will provide detailed analysis to you, okay, on your performance. And once you taking the subscription, now you can access all our live and recorded courses to watch from the comfort of any of your device. Any of your device you can use, okay, for watching of it. These are the benefits you get by joining as a plus subscriber. Now in iconic plan, see, plus subscriber, what are the benefits got by the plus subscriber? You got all the benefits. You got all the benefits. At the same time, in addition to these benefits, you get a personal coach. So this you get a one-on-one guidance from top exam expert. From top exam expert, you get a guidance, one-on-one guidance. That means for every individual student, we are providing one special coach. That is a personal coach. He is acting as a personal coach to you. That exam expert is acting as a personal coach to you. And based on your exams, what you are writing, he prepare the proper study plan and respective study material to you. Okay, and after that, study tracker. So you can get the progress in your preparation by participating in study tracker plan and study booster workshops. By participating this, you can evaluate your progress in bi-weekly reviews with personal coach. Okay, and after that, mains question and answer practice. See, if you are going to write engineering service examinations, there you need to answer the mains questions. Okay, here you can strengthen your mains answer writing capability through regular practice, and you can get evaluation and personalized feedback. So you can strengthen your mains answer writing through regular practice with evaluation and personalized feedback. Okay, you can write number of times mains question and answer practicing, and we evaluate it and we give a personal feedback to that. Due to this, you can identify the gaps in your preparation, and to fulfill those gaps, what we need to do, you can get that data. Okay, so these are the additional things you can get as a plus subscriber, as an iconic subscriber compared to plus subscriber. So here you are getting the benefits which are got by the plus subscriber. All the benefits got by the plus subscriber you are getting as iconic subscriber. In addition to that, you are getting these. Okay, next, yeah, there is a bumper offer for you. That is, who are going to writing for GATE and engineering service exam. Once they take a 12 month subscription, 12 months subscription they are taken today. For example, in the month of April, you taken a 12 month subscription, then you can get 3 extra months subscription with a free of cost. 3 months additional subscription you get till July 2022. Okay, so it is going to benefit for you once after completion of the gate. Within 2 months you are going to writing the service examinations. Okay, so now you can use that 3 month subscription for PSU exams. Okay, and you can prepare for all your PSU exams, that additional 3 months. Okay, so my dear students, don't miss this opportunity. Okay, get the subscription today itself. If you take the subscription in the month of April up to July 2022, you get the subscription. 3 months additional subscription you are getting with free of cost. Okay, don't miss the opportunity. Don't miss this opportunity. Now, so now we are going to common emitter amplifier approximate analysis. Okay, already we have some idea on common emitter amplifier. Okay, so common emitter amplifier. Common emitter amplifier. See this? Already we completed the exact analysis of CE amplifier. Okay, but in that we observed that exact model what we are using is this is your exact model what we are using. This is a CEH parameter exact model, sir. You replaced this your transistor by this exact model. So common emitter 1 by HOE, H of E into IB, IC. So it is collector, base, IB, VBE, HIE, HRE into VC. So this is the approximate model analysis of the exact model representation of H parameters. From that we can write VB is input voltage of transistor is represented by HIE into IB plus HRE into VCE, and after that IC is HFE into IB plus HOE into VCE. This is the way of representing H parameters. But here I have one problem, that is just if you observe the number of calculations, see here one multiplication I want to do, here one addition I want to do, here another multiplication. So two multiplications, one addition I want to do. So more calculations. Similarly at output side also, to get output current I want to go for two additions and another multiplication. Okay, so total 6 calculations you have to do. Okay, practically we are taking the input signal, we are sampling that. For every sample we need to apply all this, and here an exact model, more number of calculations you need to do. Now system is going to be more complex, more complicated. At the same time you need to spend more time to get the result, more money you need to spend, and you need to wait for more time to get the result. You need to wait for more time to get the result. Okay, that is the problem with exact model. Here we have some exemption. Okay, here we have some exemption, that is you can switch from exact model to approximate model. So in approximate model model, you can define your transistor by like this. This is the exact way of defining the transistor: base, emitter, and collector. This is approximate, sir. Here it is HIE, H of E, IB it is, and this is going to be the IB. It is IC, and it is IE. Okay, so this is the standard way of representing the transistor, and this is the voltage VBE. This is the voltage VCE. Okay, in approximate model, you can define VBE by only HIE into IB and IC by H of E into IB. H of E into IB. This is the approximate model representation of transistor. Okay, now the advantages to use this one is the less number of calculations are sufficient. Okay, whatever the fractional part, very small value, we are neglecting that very small value. Okay, and already previous last class we done the exact model analysis. Now we go and analyze our CE amplifier by using this approximate model. Okay, after analysis we will compare the exact model and approximate model. Okay, both we done. Approximate model representation of transistor. So this is the approximate model representation of transistor. Okay, not for CE amplifier, not for CB, not for CC. This is the approximate model representation of transistor. Now it is not specified for any of the configuration. You can use it for all configurations. In case of common emitter, you can make this is ground and common, this one input and this one output. For common base is common, emitter is input, collector is at output side. For collector is common collector is common, base is input, emitter is at output, like that. Okay, now I'm going to doing the approximate model, approximate analysis of CE amplifier now. Approximate analysis of CE amplifier. So first I'm going to taking circuit diagram. Already we are very familiar about the circuit diagrams of all amplifiers. Circuit diagram. Now so this is the circuit diagram of CE amplifier. Common emitter amplifier circuit diagram. First I am taking the properly biased transistor. R1, R2 biasing resistors. RC collector resistance. RE emitter resistance. This is the circuit diagram. Properly biased transistor. After that, common emitter you are saying. So emitter should be connected to ground through bypass capacitor CE. After that, collector connecting a capacitor. Coupling capacitors we call it CB, CC and CE. CB, CE, C. Here at base, I am connecting input voltage, input signal. It is RSVS, source voltage I am connecting to this. Source voltage. And at output I am connecting external load RL to this. This is the circuit diagram of CE amplifier. Okay. After that, I am going to taking AC equivalent circuit. To get the AC equivalent circuit, what we have to do, we know everything. Capacitors are short circuited, external capacitors CE, CB, CC, and DC supply plus VCC connected to ground, and rearrange the circuit. Simple. Here R1 parallel with R2. After that, we take that parallel combination is RB, and RC parallel with RL, we take it as RL dash. So next, second one is AC equivalent circuit. Circuit. For AC equivalent circuit, now directly I am going to that, because already we completed this part, how to draw the circuit, everything we completed. For common emitter, emitter should be connected to ground. Emitter should be connected to ground. So this is the transistor with the emitter towards ground side. So for AC equivalent, emitter CE amplifier, so it is the emitter connected to ground. At base, we have RB. Collector, we have RC. And we are connecting a external load RL to this, taking the output. Here we are giving input just by connecting RSVS. Just by connecting RSVS. Okay. So by connecting this, so this is the representation of transistor CE amplifier AC equivalent circuit. Now here both you observed RC and RL both are in parallel. Now I am taking it as RL dash, which is RC parallel with RL. This is the base current. This is the collector current IC. Here is the voltage between collector to emitter. Here is the voltage between base to emitter, VBE. Okay, and here we take the input impedance Ri. Here we take the Ri dash. Here we take the RIS. By making RS 0, VS 0, here you can take R0. Here you get R0 dash. Here you get R0 double dash. Simple. Now I am going to replacing transistor by its approximate model. Okay. So Now replacing transistor by approximate model. Approximate model. Okay, so I'm going to replacing transistor by approximate model. So this is the approximate model representation of your transistor. Emitter, sorry, input side base, collector and emitter. Now it is HIE, HFE, IB. So in that, this is IB, it is IC, and emitter connected to ground. At base we have first biasing resistor RB. At collector we have RC, and after that we have RL. Now here at input side we have RSVS. RSVS. For my easy understanding purpose, I am going to connecting all these grounds like this. Now this is the voltage base to emitter. This is emitter, means it is also emitter. It is also emitter. So this voltage is VBE. This voltage is VCE. From output side, it is output voltage V0. Okay, now this is going to be your input voltage, input impedance Ri. It is Ri dash including biasing resistor and including source resistance RIS. Now by applying KVL to input loop, we can write this is IB, fine. This is your IE. Now at input I am applying KVL. VBE equals to voltage between this point to this point is IB into HIE plus 0. So VBE is equals to, from this, HIE into IB, and IC you are saying, but it is HFE into IB from this. Into IB. Okay. So I am copying the circuit once for reference purpose. Now, so these are the values of VB and IB, IC. Now I am going to calculating one by one parameter. First parameter is current gain, AI. So we know AI is minus IC. This is IC and this is minus IC. Minus IC by IB. But minus IC is nothing but a H of A into IB. H of A into IB by IB. So both will get cancelled. So it is minus H of A. That's it. Second one is input impedance Ri. Ri. Okay. So RI is written as input voltage VBE by IB. So from this, VBE is HIE into IB by IB. So which is HIE. Simple. RI is HIE. Next I am writing, once you know the RI, you can go and write the circuit like this. See this? Once you know the RI, you can write your circuit like this. See this? You can write your circuit like this. So between base to emitter, just before we have RI. Okay, this is your IB. This voltage is VBE. Can enhance it, and the voltage between these 2 points also VBE. From this, we can write VS, RS. Now RB parallel with RI, that is nothing but RI dash. We called it effective input impedance. This is the voltage, it is RI dash. So now RI dash is RI parallel with RB. Here is VBE. Now I am writing VBE value from this, which is voltage division. Just I am applying VS into RI dash by RI dash plus RS. Therefore, VBE by VS is RI dash by RI dash plus RS. Okay, just keep this equation like this. In AVS, we are going to use this expression. Okay, this is about RI dash. That means this is effective input impedance. Effective input impedance. After that, input impedance including source is RIS. Okay, and RIS is RS plus RI dash. This is your RIS. RIS is RS plus RI dash. That's it. Okay. RI dash plus RS. That is the effective input impedance. That's it. Effective input impedance, this one, and this is the input impedance including source resistance. Okay, including source resistance. And after that, so input impedance and current gain is over. Now we are going to voltage gain. So next, voltage gain. Third one. So voltage gain is AV, which is output voltage by input voltage. So VCE is nothing but this is IC and this is minus IC. And this whole thing is RL dash. So V0 is nothing but a VCE, which is minus IC into RL dash. And this is your input impedance RI. So from this VCE I am writing it as minus IC into RL dash by VBE. So you are writing RI is VBE by IB. From this I am writing VBE equals to RI into IB. So which is RI into IB. Now minus IC by IB into RL dash by RI. So which is AI into RL dash by RI. That is the voltage gain. AI into RL dash by RI. Just substitute the AI value. Therefore, AV is voltage gain AI minus H of E into RL dash by RI. You observed or not, current gain is minus H of E. There is a negative. Similarly, voltage gain also a negative. It represents output signal is 180 degrees phase shifted. Output signal is 180 degrees phase shifted. That is the meaning of that. This is voltage gain. Next one is voltage gain including source resistance. Okay. Next, voltage gain including source resistance. Source. So we can write it as AVS, which is output voltage by source voltage. Now I am multiplying and dividing this with VBE. See, V0 is nothing but a VCE. It is VCE by VS. Now I am writing this is multiplying and dividing with VBE both sides. So VC by VBE is nothing but a, this is nothing but a voltage gain AV. And already we calculated this previously, which is RA dash by RA dash plus RS. That is AVS. So once you added the source, so that source, by adding source, gain is going to be decreasing. So AVS is less than AV. AVS is less than AV. Okay, that is the AVS value, voltage gain including source resistance. So AV into RA dash by RA dash plus RS. That's it. Next, AIS, voltage current gain including source. Including source. See, for that, so once I'm going to replacing VS RS by IS RS. This is the current source. This is ISRS. It is going to be connecting to base and emitter. So before going to connecting to base and emitter, in between this we have it is base and here we have emitter. Between base to emitter we have RI, input impedance. RI. This current is IB. This is RI. Okay. And one more. Between this we have biasing resistor RB. Now, our intention is to calculate the current gain including source. That is AIS actually. Which is a minus IC by, instead of IB I am taking it as IS. So which is minus IC by IB into IB by IS. That's it. But we know this value. But we know minus IC by IB value. Minus IC by IB value is AI, current gain, AI. Okay. Now, we need IB by IS. For that, I am going to simplifying this circuit. This part RS by RS parallel with RB I am taking as RS dash. So RS dash is RS parallel with RB. RS parallel with RB. Now the circuit is like this. This is RI, base, emitter. This is IB, it is RS dash. From this, I am going to apply, we need IB by IS. We need to calculate this. From this, here I am going to apply current division. Just I am applying current division here. Okay. So by applying current division, we can write. So we can write it as IB is IS into RS dash by RS dash plus RI. From this, IB by IS is written as RS dash by RS dash plus RI. That's it. So therefore, AIS, current gain including source, is AI into RS dash by RS dash plus RI. That is the current gain. Okay, including source. So next one is we need to calculate output impedance. Output impedance. So that is R naught. So we can write R naught is output voltage by output current at the rate of Vs equals to 0 and RL disconnected. Disconnect. Already we disconnected the RL. Here output voltage is VCE and IC is output current is IC. So now we need V0 by V0 is nothing but a VCE by IC at Vs equals to 0. Now whatever the Vs here we have, this is our Vs. Now I am going to connecting this Vs 0. I want to make this one 0. Once I short circuit this Vs equal to 0, then RS and RB both are parallel. That parallel combination I am taking it as RS dash. Now the equivalent circuit after making a Vs0 is RS dash base HIE like this. This is the current IB. By applying KVL to this loop, we can write IB times RS dash plus HIE equals to 0. Therefore, IB equals to 0. Once IB is 0, we know IC is H of E into IB. That means it is 0. Once IC 0, substitute 0 here. Therefore, R naught is VCE by 0. It is infinity. R naught is infinity. R naught is infinity. Now that means whatever the collector and emitter terminals we have, between these two we have a R naught, and that R naught value is infinity. But in practically we have Between collector to emitter, we have not only R naught, between these two we are connecting RC also. Already we have RL, sorry, already we have R naught in infinity. Now including RC, we called it R naught dash, that is R naught parallel with RC, that is infinity parallel with RC, which is RC. Next we have R naught dash, and after that, in addition to this, here we have RL, external load resistance RL. Now we called it R naught double dash, that is R naught dash parallel with RL, which is RL dash. That's it. Okay, this is about parameters. Now what are the parameters so far I got here? I am going to placing all the parameters at one point. Approximate CE parameters, CE values. First one is current gain AI minus H of E. Second one, input impedance RI HIE. See how simple it is. And after that you go for RI dash. RI dash is equals to RI parallel with RB, and RIS is RS plus RI dash. And after that, voltage gain AV is AI into RL dash by RI. So that is a minus H of E into RL dash by RI is HIE. And next AVS, which is AV into RI dash by RI dash plus RS. After that, AIS, current gain including source resistance, AI into RS dash by RS dash plus RI, where RS dash is equals to RS parallel with RB, input biasing resistor. And last one is output impedance R naught is in infinity. Okay, and R naught dash is RC. Like that, based on the point where they want, you can go and take that point. These are the approximate H parameter values of CE amplifier. So this is the way to analyze the amplifier. Next session, see, if you observe one thing in this circuit, your emitter is directly connected to ground due to bypass capacitor. This is called emitter bypass capacitor. Okay, there is a much importance for that. What is that importance and everything we discuss later. Emitter bypass capacitor, there is importance for that. What is that importance and what is that everything we discuss in the next session. Okay, so this is a CE amplifier, and sometimes you call it as a CE amplifier with bypass capacitor. With the bypass capacitor, with the bypass capacitor, in this sense there is no emitter resistance in AC equivalent circuit. That means in DC point of view emitter is present, in AC point of view emitter is absent, in AC signal point of view. That is the difference. Okay, like this you can analyze your CE amplifier. Next session we go to CE amplifier without bypass capacitor. So here I am going to showing some of the top educators from Unacademy. So I am expecting next you are going to be at this level. See this Tiwari sir, he is the IIT topper and he has 7 years of GATE and engineering service teaching experience. He is author of the book GATE in 75 days. And Ankit Goyal sir, he obtained All India first rank twice in GATE Electrical. He was awarded President of India Gold Medal in IIT Indore. Jaspal Singh sir, he is ex-IAS officer. He got All India 4th rank. He is a scientist, GATE, State Service Exams and PSU topper and ex-senior MEDESE faculty. He has more than 12 years of experience. And Sanchit Jain sir, he is a computer science faculty having experience more than 8 years. And here are the few more top educators from Unacademy. Here are few more. Now, just a glance, what are the different engineering disciplines available in Unacademy for GATE and engineering service exams? First one is electronics and communication engineering. Next one is chemical engineering, mechanical engineering, computer science and IT departments, instrumentation engineering, electrical engineering, next civil engineering, and production and industrial engineering. These are the different engineering disciplines available in Unacademy. Next, there are two plans. First one is a plus plan, other one is iconic plan. Plus plan is the basic plan. Iconic plan will take your GATE and engineering service preparation to next level with personal coach. Now in both the cases, India's best educators are handling your subjects. Interactive live classes are there, structured courses and PDFs are there, and live tests and quizzes are there. Here we are going to show the difference between plus subscriber and iconic subscriber. In iconic subscriber, once they've written the exam, that paper is forwarded to the personal coach. Personal coach is do the analysis on that. We called it personalized test analysis. After that, they prepare a proper study planner to him, and respect to study material also they will provide. Okay, this is about plus and iconic subscriptions. And one more thing, if you are taking 1 year subscription for anyone, either plus or iconic, 3 years additional benefit you are going to be getting. That means if you are taking subscription for 12 months, you are going to getting 15 months, 3 months free. If you take subscription this month of April, it will be valid for July 2022. Now in plus plan, there are different subscriptions: 1 month, 3 months, 6 months, 1 year, 1.5 year and 2 years. For 1 year, it is 30,250 rupees. By using my code VRAO10 during subscription, you get it by 10% discount, that is 27,225 rupees. Iconic plan. So it is available in 2 subscriptions, 1 year subscription and 2 year subscription. For 1 year, it is 50,250 rupees. By using my code VRAO10 during subscription, you get it by 10% discount. After that, it became 45,225 rupees only. Thank you. Thanks for spending your valuable time with us. Don't forget to use my code VRAO10 during subscription. And subscribers, please give your valuable comments. And please hit the bell icon. Join our Telegram group for getting latest updates on our upcoming videos. Thank you very much. Thanks for spending your valuable time with us. Thank you.